Objective 10, be able to write electron arrangements for neutral atoms or ions using orbital diagrams, full configurations, or noble gas configuration. Also recognize IB's method where calcium would be 2882. So for calcium, if I look, it's element number 20. So I've got 20 electrons to place. It's in period 4, and I see it's in the second family or in the s block. So the orbital diagram, the 1s is going to be filled up since first floor is full. The second floor is full, so the 2s and the 2p are also going to be filled up. The third floor is also full, at least the 3s and the 3p. And then I come around to the fourth energy level, and I know the 4s would be the first thing to fill there. And it's also going to have 2 electrons. And if I go back and count, I've got 2, 4, 6, 8, 10, 12, 14, 16, 18. I have 20 electrons. If I'd been asked to do this for calcium +1 or +2, then I'd remove 1 or 2 electrons from the 4s orbital. For the full configuration then, it's just a matter of using exponents instead of the boxes. So 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. The noble gas configuration, I go back to the end of period 3 and I use the noble gas argon. And since argon is 18, that means I only have 2 more electrons to place. And since I'm in the 4th energy level, I would place them in the 4s orbital, or it would be argon 4s2. And then the IB configuration, the way they came up with the 2882 is they look at each energy level. Energy level 1 has just 2 electrons in it. Energy level 2 has 2 plus 6, or a total of 8 electrons. Energy level 3 also has 8 electrons, and energy level 4 has just 2. And when you get to bigger elements with the D block filled, you can end up with 18 electrons, or you get to the really big ones that have D and F blocks filled, you could have 32 electrons for any energy level.